Welcome to Chapter 1, Introduction to Environmental Science. This is the first lecture entitled Our Island Earth. The term environmental science is made up of, two words, environment and science. Let's start with the first, the environment. Once upon a time, the term environment just meant surroundings. It was used in reference to the physical world, separate from ourselves, rocks, soil, air, and water. People gradually came to realize that the organisms that inhabit the physical world, the enormous variety of plants, animals, and microorganisms on this planet, including humans, are an integral part of the environment. The environment includes both living or biotic and non-living or abiotic things. A fundamental insight of environmental science is that we are part of the natural world and that we are dependent on a healthy, functioning planet. The second term, science, we'll have a further discussion on in a future lecture. Science is a way of knowing. It's a way of testing predictions and understanding how things work. Environmental science, then, is the study of how the natural world works, how our environment affects us, and how we affect our environment. We know our actions modify the environment, and even actions that enrich our lives can have unintended consequences and degrade the environment. We also know that we are able to come up with creative solutions to problems if we put our minds to it. Natural resources lie on a continuum from perpetually renewable resources such as sunlight and wind energy to non-renewable such as crude oil or natural gas. This continuum is a progression of values. So we know that these natural resources that come from nature, are vital to our survival. The USGS, the U.S. Geologic Service, defines natural resources of the U.S. as the nation's natural resources include its minerals, energy, land, water, and biota. We can, as we said, we can take the natural resources and we can classify them as renewable, things like sunlight, wind energy, wave energy, and geothermal energy, which are perpetual, right? They cannot be depleted. And things that are depletable, that are non-renewable, like crude oil, natural gas, coal, and many metals. In the middle is a group that includes agricultural crops, fresh water, forest products, and soils that we could call potentially renewable. If we use them carefully, if we conserve them as we use them, they are renewable. But we can overuse them and deplete them. Another introductory idea to the course is that we need to think about human population over the last, say, 10,000 years. Because global population growth has shaped our resource use. Right? The more humans, the more resources needed, the more likely we are to deplete those resources. There are currently over 6 billion people on the planet. You can see somewhere around 6.7 billion at one of the latest estimates I've seen. And you can also see that there has been a dramatic growth of population over this last time span. I want to note to you that there has been two major events in history of humanity that sort of triggered the increase in population. The first, as you can see, around 10,000 years BP, which means before present, humans began to cultivate crops and work with animals and domesticate them and that led to the ability to stay put. So it was a transition which occurred over a long period of time, where humans transitioned from mainly hunter-gatherer lifestyle to a mainly agricultural way of life. The second major revolution is the Industrial Revolution. It began in the 1700s and involves a shifting from a rural agricultural life to an urban society powered by fossil fuels, oil, coal, natural gas. These two events have led to this tremendous growth in human population on the planet. There have been a number of discussions over time about population growth and whether human population growth is a good thing. And there's intriguing ideas on both sides. The book discusses some of the ideas of Thomas Malthus and his essay entitled An Essay on the Principle of Population, basically saying that population growth will lead to starvation, war, and disease, and that unless population growth was controlled, the number of people would outgrow the food supply. Okay. There has been a group of scientists in the more current times, we sometimes call them neo-Malthus, right? Or neo-Malthusians. It's a difficult one to say. Most famous is Paul Ehrlich. He's a scientist from Stanford, and he first wrote the book Population Bomb. It was published in 1968. Many of the same ideas. Rapidly increasing population equals widespread famine and conflict, a depletion of natural resources, and not enough to go around. Another important idea discussed in the first chapter is the tragedy of the commons. Again, this was published in the journal Science in 1968. It's a pretty famous essay. It discusses the term commons. Commons are areas that are open to all and they're unregulated use. So the idea is that if there's an area that everybody can use and there's an economic benefit for them to use that area, that they will likely overuse and deplete that area, that commons. So that unregulated exploitation of the commons depletes the commons. A couple of examples are included in the text for you to look at. The first is one very similar to Garrett Hardin's original storyline, which is about a pasture land and soil depletion from overgrazing. And the second involves a lobster fishery as a commons. The last idea I want to talk about from this initial lecture is the concept of the ecological footprint. This was originated by an economist named Wackernagel, quite a name. And the idea here is pretty simple in concept. How much land and water is needed to sustain your individual lifestyle, right? To get the resources that you need and provide the waste assimilation, the ability to clean up and dispose of waste from your lifestyle. This can be done for an individual or for a family or can be computed for a nation or the entire planet. The environmental footprint expresses the environmental impact of an individual or population in terms of the cumulative amount of land and water required to provide the raw materials, the natural resources consumed, and to recycle the waste produced. The environmental footprint then totals the amount of Earth's surface, utilized, and gives you sort of an answer of how much land area. Normally that's in hectares, which is essentially 100 meters by 100 meters, or roughly the size of a football field in length on each side of a square. so very similar to that size. When we'll look at this and calculate the ecological footprints for our own lifestyles and have a discussion on that as we go on. All right, thanks for joining me for this lecture, and make sure and go back to the book and review some of these concepts and send me any questions that you have.